Every substance around us is made up of atoms. They are incredibly small particles that build all the material in the entire universe. We talked about atoms and molecules when we discussed the kinetic particle theory of matter in previous videos. However, a substance made up of just one type of atoms is called an element, like sodium element or nitrogen element. And elements can't be broken down into anything smaller by chemical reaction. So you can't break down a nitrogen or oxygen element or any other element in the periodic table. There are now 118 known elements, but most of the mass of the known universe consists of just two elements: hydrogen with 92% of the mass of the universe and helium with 7% of the mass of the universe, with the other elements contributing only with 1% of the total mass of the entire universe. But how can a certain number of these elements concentrated together to form the Earth? There are 94 elements found naturally on Earth, but just 8 accounted for more than 98% of the mass of the Earth's crust. 2 of these are oxygen and silicon, which are bonded together to give silicate rocks that make up almost 3/4 of the crust. Only certain elements are able to form the complex compounds that are found in living things. For instance, the human body contains 65% oxygen, 18% carbon, 10% hydrogen, 3% nitrogen, 2% calcium, and 2% of the other elements. Keep in mind that there is a difference between elements and compounds. Elements are substances that cannot be broken down into smaller particles by a chemical reaction, like oxygen for instance, where compounds are substances formed by the chemical combination of 2 or more elements in fixed proportions, like water for instance. It combines hydrogen and oxygen elements in fixed proportion. Our modern understanding of the atom is based on the atomic theory put by the chemist John Dalton in 1807. Dalton's idea was that atoms were the basic building blocks of the elements. He thought of them as invisible particles that could join together to make molecules. Although certain parts of the theory have had to change as a result of what we have discovered since Dalton's time, his theory was one of the great theories explaining the atom. It helped explaining many natural processes. Whereas Dalton only had theories for the existence of the atom, modern techniques can now directly reveal the presence of individual atoms. Research since Dalton's time has shown that atoms are made up of several subatomic particles, and by subatomic, I mean particles that are smaller than the atom itself. And these subatomic particles are protons, neutrons, and electrons. And the distribution of these particles is pretty simple, and it goes like this. At the center of the atom, there is the nucleus, and it contains the protons and the neutrons inside. Outside the nucleus, we have the electrons rotating the nucleus. Now when it comes to the characteristics of these subatomic particles, protons carry a positive charge, and they are given a relative mass of 1. Neutrons are neutral and have the same mass as protons. Finally, electrons. They are negatively charged and they have virtually no mass. These particles are universal, which means that all atoms in the universe are made from them in that exact distribution. Even though atoms contain electrically charged particles, atoms themselves are electrically neutral, which means that they have no overall charge. This means that in any atom, there are an equal number of protons and electrons. This way, the total charge of the atom is neutral due to the balance made by the opposite charge of protons and electrons. The simplest atom in the universe is hydrogen atom. It has one proton in its nucleus, and it's the only atom that has no neutrons. It consists of one proton and one electron rotating that proton. The next simplest atom is helium. Helium has two protons and two neutrons in its nucleus, and it has two electrons orbiting the nucleus. Lithium is the third next simplest atom after helium. A lithium atom has 3 protons, 4 neutrons, and 3 electrons. The subatomic arrangement of the larger atoms get more complicated with the addition of more protons and electrons. The number of protons required to hold the nucleus together increases as the atomic size increases. For instance, an atom of gold consists of 79 protons, 118 neutrons, and 79 electrons. We mentioned earlier that hydrogen atoms have one proton in their nucleus, and hydrogen is the only element in the universe that has this number of protons. We also mentioned that helium atoms have 2 protons. They're also the only atom in the universe that has only 2 protons. The point that I'm trying to make is that the number of protons in the nucleus of an atom is specific for each element. It's actually what determines which element this atom is going to be. This important number is known as the proton number or atomic number. And the atomic number is the number of protons in an atom. And the proton number is given the symbol Z. We've seen that protons alone do not make up all the mass of an atom. The neutrons in the nucleus also contribute to the total mass, because protons and neutrons have the same relative mass. The mass of a particular atom depends on the total number of protons and neutrons in that atom. Protons and neutrons are known as nucleons, and the total number of protons and neutrons in an atom is called the mass number or the nucleon number. This number actually represents the mass of a whole atom, and the mass number is given the symbol A. Let's make a quick comparison here between the mass number and the atomic number. The atomic number is the number of protons only in the nucleus of an atom, and it's symbolized as the letter Z, where the mass number is the total number of protons and neutrons in the nucleus of an atom, and it's symbolized as the letter A. An important way of representing a particular atom of an element is to combine the chemical symbol of the element with the atomic and mass numbers of that element. The symbol Z representing the proton number and the symbol A representing the mass number of an element can be written alongside the symbol for the element. In a general way, that is how we write the element symbol, with the X being the element symbol. For a more specific example, hydrogen element has the symbol H and an atomic number of 1 and has a mass number of 1 as well, so we can write it like this. Keep in mind that in a neutral atom, the number of protons is the same number of electrons. This means that in a neutral atom, the atomic number is not only the number of protons, it's also the number of electrons. But as we said, that's only applicable in neutral atoms. Using what we have learned earlier in this video, an atom of lithium is represented as this symbol. How many protons, neutrons, and electrons does this atom has? The answer is pretty easy. The number 3 represents the symbol Z, which is the number of protons. Now, since this is a neutral atom, the number of protons is the same number of electrons. So we have 3 electrons as well. Finally, the number 7 represents the mass number, which is the number of protons plus the number of neutrons. Well, we have 3 protons and the mass number is 7. With simple math, this means we have 4 neutrons. This was everything for today's video. Like and subscribe for the channel for more videos.